Uranus drifts through the distant reaches of the solar system, a world so far from the Sun that it exists in a realm of perpetual twilight, a quiet corner of space where sunlight arrives weak and pale after traveling across vast emptiness. It is the seventh planet from the Sun, positioned beyond Saturn in a region where the inner warmth of the solar system has long since faded, replaced by the cold stillness of the outer darkness. Uranus moves along its orbital path with a slow patience, taking 84 Earth years to complete a single journey around the Sun, a leisurely circuit that speaks to the unhurried nature of this distant world. The planet appears as a pale blue-green sphere when viewed through a telescope or in images captured by spacecraft, a soft aquamarine color that gives it a serene and peaceful appearance. This gentle hue comes from methane in the planet's upper atmosphere, a gas that absorbs red light from the Sun while allowing blue and green wavelengths to reflect back into space. The methane is present in small amounts, mixed with the hydrogen and helium that make up most of the atmosphere, but it is enough to color the entire planet in these soothing tones, creating a world that looks cool and calm, wrapped in layers of soft blue cloud. Uranus is classified as an ice giant, a type of planet different from the gas giants Jupiter and Saturn. While those larger worlds are made mostly of hydrogen and helium, Uranus contains a much higher proportion of heavier materials, substances that astronomers call ices even though they are not necessarily frozen solid. These ices include water, methane, and ammonia, compressed under tremendous pressure in the planet's interior, existing in states that are neither fully liquid nor fully solid but somewhere in between. The core of Uranus may contain rock and metal, but most of the planet's mass is made up of these ice materials, giving it a composition and structure that sets it apart from its larger neighbors. The atmosphere of Uranus appears remarkably smooth and featureless when compared to the turbulent clouds of Jupiter or Saturn. There are no prominent storms, no giant spots or dramatic swirls that catch the eye. Instead, the planet presents an almost uniform face, a calm blue-green disk that shows only the subtlest variations in shade. This smoothness gives Uranus a tranquil quality, as if the planet exists in a state of perpetual calm, undisturbed by the vigorous weather that affects other worlds. Occasionally, small bright clouds appear, tiny features that drift through the upper atmosphere before fading away, but these are rare and temporary, brief interruptions in an otherwise peaceful expanse. One of the most distinctive characteristics of Uranus is its unusual tilt. Most planets rotate with their axes roughly perpendicular to the plane of their orbits, spinning like tops as they circle the Sun. Uranus, however, is tilted so far over that it essentially rolls along its orbital path on its side, its axis lying almost within the plane of its orbit. This extreme tilt means that during certain parts of its year, one pole points nearly directly at the Sun while the other pole faces away into darkness. As Uranus continues along its orbit, the illumination gradually shifts, and eventually the opposite pole becomes the one facing the Sun, creating a pattern of seasons unlike any other planet in the solar system. The cause of this unusual tilt is thought to be a collision or series of collisions early in the solar system's history, impacts with other large bodies that knocked Uranus onto its side. Whatever the exact sequence of events, the result is a planet that presents a unique orientation to the Sun, rotating in a way that seems almost sideways compared to the orderly spinning of the other worlds. This tilted rotation gives Uranus its own particular character, a planet that does things differently, moving through space in its own distinctive way. The seasons on Uranus are long and extreme because of this tilt and the planet's distant orbit. Each pole experiences 42 years of continuous sunlight followed by 42 years of continuous darkness as Uranus makes its slow journey around the Sun. During the summer at one pole, that hemisphere is bathed in weak but constant sunlight for decades, while the opposite hemisphere remains in shadow. When Uranus reaches the other side of its orbit, the situation reverses, and the pole that was in darkness now faces the Sun. The equatorial regions experience a more regular cycle of day and night as the planet rotates, but even these regions are affected by the changing angle of sunlight as the seasons progress. If you're still awake, that's perfectly fine. Let your thoughts drift along with Uranus in its distant orbit, moving slowly through the outer solar system, a world wrapped in pale blue clouds, turning quietly in the darkness. Uranus is much smaller than Jupiter or Saturn but still far larger than Earth. 4 Earths could fit across its diameter, and the planet's volume could contain more than 60 Earths. Despite this size, Uranus is not particularly massive because of its lower density, a consequence of being made largely of ices and gases rather than heavier rock and metal. The gravity at the cloud tops is slightly less than Earth's surface gravity, creating an environment that, while still substantial, would not feel dramatically different from what we experience here at home, though of course there is no solid surface to stand upon, only layer upon layer of atmosphere gradually becoming denser as you descend. The planet rotates fairly quickly, completing one rotation in about 17 hours. This rotation creates a slight flattening at the poles and a bulge at the equator, though the effect is less pronounced than on Jupiter or Saturn. The rotation also helps to organize the atmospheric circulation, though the patterns are different from other planets because of the unusual tilt. The winds on Uranus blow at moderate speeds, not as fast as the fierce jets on Saturn but still substantial, carrying clouds and haze around the planet in organized flows. The interior of Uranus is not well understood because we cannot see inside the planet, but models based on gravity measurements and other data suggest a layered structure. At the center there may be a small core of rock and metal, surrounded by a thick mantle of compressed ices, water, methane, and ammonia existing under tremendous pressure and temperature. Above this mantle is the atmosphere, a layer of hydrogen and helium with traces of methane and other compounds, gradually thinning as it extends outward into space. The transitions between these layers are not sharp but gradual, with each zone blending into the next in a slow continuum. Uranus generates very little internal heat compared to the other giant planets. Jupiter, Saturn, and Neptune all radiate significantly more energy than they receive from the Sun, heat left over from their formation and generated by ongoing contraction and other processes. Uranus, however, radiates almost no excess heat, appearing to be in thermal equilibrium with the sunlight it receives. The reason for this is uncertain, but it may be related to the same collision that tilted the planet, an impact that perhaps disrupted the interior and allowed heat to escape more efficiently, leaving Uranus cooler than it would otherwise be. This lack of internal heat contributes to the planet's calm appearance. Without significant heat rising from below to drive vigorous convection, the atmosphere remains relatively quiet, lacking the energy to generate the large storms and complex cloud patterns seen on other giant planets. The result is a world of subtle beauty, a smooth blue-green sphere that appears peaceful and serene, a planet where change happens slowly and dramatic events are rare. Uranus has a magnetic field, though it is unusual in its structure. Unlike Earth's magnetic field, which is roughly aligned with the planet's rotation axis, Uranus's magnetic field is tilted at nearly 60 degrees to the axis and is offset from the planet's center. This creates a complex and asymmetric magnetic field that wobbles as the planet rotates, creating a magnetosphere that is unlike any other in the solar system. The exact reason for this unusual configuration is not fully understood, but it may relate to the way the magnetic field is generated within the planet's ice mantle rather than in a central core. The magnetosphere of Uranus interacts with the solar wind, creating a protective bubble around the planet, though the interaction is complicated by the tilted rotation and the off-center magnetic field. As Uranus rotates, the magnetosphere rocks back and forth, creating a dynamic environment that changes significantly over the course of each 17-hour day. Charged particles are trapped within the magnetosphere, and they can interact with the rings and moons, contributing to the slow evolution of these features over time. As we drift onward, we can think about the rings of Uranus, which were discovered relatively recently, not visible from Earth until modern instruments and techniques revealed them. The rings are very thin and dark, made of particles that reflect very little light, quite different from the bright icy rings of Saturn. The ring particles are mostly small, ranging from dust-sized grains to chunks a few feet across, and they are dark gray or black in color, suggesting they may be made of organic compounds or radiation-darkened ice. The rings orbit the planet in the equatorial plane, which means they too are tilted dramatically relative to the orbital plane, standing almost vertically from our perspective at certain times during Uranus's year. There are 13 known rings, most of them narrow and faint, separated by gaps where particles are less common. The rings are named with numbers and Greek letters, a simple naming scheme that reflects their order of discovery and position. The outermost ring, called the Epsilon ring, is the brightest and most substantial, though even it is faint compared to Saturn's magnificent ring system. The rings of Uranus are confined and shaped by small moons that orbit among them, shepherd moons that use their gravity to keep the ring particles in narrow bands. These moons are small and dark, difficult to see even in close-up images from spacecraft, but their gravitational influence is clear in the sharp edges and narrow widths of the rings. The rings may be relatively young, perhaps the remnants of moons that were shattered by impacts, or they may be continually replenished by dust knocked off the nearby moons by micrometeorite impacts. If you're still awake, that's perfectly fine. These gentle facts about Uranus are here simply to accompany you, flowing past like clouds in the planet's distant atmosphere, each one a small piece of information drifting quietly through your awareness. Uranus has 27 known moons, each one named after characters from the works of William Shakespeare and Alexander Pope, a departure from the mythological names used for most other planetary satellites. The largest moons are Miranda, Ariel, Umbriel, Titania, and Oberon, worlds ranging in size from a few hundred miles to nearly 1,000 miles across. These moons orbit in the planet's equatorial plane, which means they too share the extreme tilt, following paths that seem almost vertical at certain times in Uranus's year. Titania is the largest of Uranus's moons, a world of ice and rock with a surface that shows evidence of past geological activity. The surface is marked by long valleys and scarps, features that suggest the Moon's crust has been stretched and fractured, perhaps by expansion as the interior froze and increased in volume. Titania's surface is relatively bright compared to some of the other moons, covered in water ice that reflects sunlight and creates a landscape of subtle variations in shade and texture. Oberon is the second largest moon, similar in size to Titania but with a darker surface that shows more impact craters. The craters on Oberon are ancient, marking impacts from billions of years ago when the solar system was young and collisions were more frequent. Some of the larger craters have dark material on their floors, possibly deposits from the interior that emerged when the impacts occurred, though the exact nature of this material is uncertain. Umbriel is the darkest of the large moons, its surface a deep charcoal gray that reflects very little light. The darkness may come from ancient organic compounds on the surface, material that has been altered by radiation over billions of years. Umbriel's surface is heavily cratered, showing little evidence of recent geological activity, suggesting a world that has remained largely unchanged for eons, preserving a record of the early solar system. Ariel is brighter than Umbriel and shows more signs of past geological activity. The surface has valleys and fault scarps, long cracks where the crust has been pulled apart, creating features that suggest internal processes once shaped the Moon. Some regions appear younger than others, with fewer craters, indicating that volcanic or tectonic activity has resurfaced parts of Ariel more recently in geological time, though even these young regions are ancient by human standards. Miranda is the smallest of the 5 large moons but perhaps the most geologically diverse, with a surface that shows a strange patchwork of different terrain types. There are areas with parallel ridges and grooves, regions with smooth plains, and zones with chaotic jumbled terrain, all existing side by side in a pattern that has puzzled scientists since the Moon was first seen clearly. The varied terrain suggests that Miranda experienced significant geological activity in its past, possibly driven by tidal heating from gravitational interactions with the other moons, though the exact sequence of events that created the surface we see today remains uncertain. The smaller moons of Uranus are irregular in shape, dark in color, and heavily cratered, small rocky worlds that orbit farther from the planet. Some of these moons may be captured asteroids, objects that formed elsewhere in the solar system and were pulled in by Uranus's gravity. Others may be fragments from collisions between larger bodies, pieces that have remained in orbit around the planet since they were created. These small moons are difficult to study because of their size and distance, but each one adds to the diversity of objects in the Uranus system. Slowly, as we drift onward, we can think about the distance that separates Uranus from the Sun, a vast expanse of nearly 2 billion miles that isolates the planet in the cold outer reaches of the solar system. At this distance, the Sun appears as a bright star rather than a disk, providing only a tiny fraction of the light and heat that reaches Earth. The sunlight that illuminates Uranus left the Sun more than 2.5 hours earlier, crossing the solar system at the speed of light to reach this remote world. The coldness of Uranus is profound. The temperature at the cloud tops is around -350 degrees Fahrenheit, one of the coldest temperatures measured in any planetary atmosphere in the solar system. This extreme cold is a consequence of the great distance from the Sun and the lack of internal heat, leaving Uranus to exist in a state of deep freeze that has persisted for billions of years. The cold affects everything about the planet, from the chemistry of the atmosphere to the behavior of the ices in the interior, creating conditions that are very different from the warmer environments closer to the Sun. Despite the cold, there is still weather on Uranus, though it is subtle and difficult to observe. Clouds form in the upper atmosphere, small bright features that appear and disappear over days or weeks, carried along by the planet's winds. These clouds are likely made of methane ice crystals, condensed from the trace amounts of methane in the atmosphere, forming when conditions are right and then evaporating when temperatures change. The clouds are faint and require careful observation to detect, but their presence shows that the atmosphere is not completely static, that there are still processes at work creating change and variation even in this distant and quiet world. The winds on Uranus blow in the same direction as the planet's rotation in the equatorial regions, and they can reach speeds of several hundred miles per hour. These winds are not as fast as those on Saturn or Neptune, but they are still substantial, driven by the weak sunlight and the planet's rotation. The wind patterns are organized into bands, though the bands are subtle and difficult to see because of the uniform appearance of the atmosphere. The existence of these winds shows that even with minimal energy input, a planet can still develop organized circulation patterns, systems that persist over long periods of time. If you're still awake, that's perfectly fine. Let these thoughts about Uranus drift through your mind, gentle and undemanding, a slow stream of information about this distant ice giant, rolling through space on its side, wrapped in pale blue clouds. Uranus was discovered in 1781 by William Herschel, an astronomer who initially thought he had found a comet. Further observations showed that the object was moving in a planetary orbit, and it was soon recognized as a new planet, the first to be discovered in modern times. The discovery of Uranus expanded the known solar system, showing that there were worlds beyond the classical planets known since antiquity, and it opened the way for the later discoveries of Neptune and the many smaller objects in the outer solar system. For nearly 2 centuries after its discovery, Uranus was observed only from Earth, a small greenish disk that showed little detail even in the best telescopes. Astronomers measured its orbit, discovered its major moons and rings, and noted the unusual tilt of its rotation axis, but the planet itself remained largely mysterious, too distant and too faint to reveal much about its atmosphere or internal structure. It was not until 1986 that a spacecraft finally visited Uranus, providing the first close-up views of this remote world. The spacecraft was Voyager 2, a probe that had been launched years earlier to explore the outer solar system. Voyager 2 had already visited Jupiter and Saturn, sending back detailed images and data from those giant worlds, and Uranus was the next stop on its grand tour. The spacecraft flew past Uranus in January of 1986, passing close to the planet and several of its moons, taking thousands of images and making measurements of the magnetic field, atmosphere, and ring system. The images from Voyager 2 showed Uranus as a smooth pale blue sphere, almost featureless in visible light, confirming what had been suspected from Earth-based observations. The spacecraft discovered 10 new moons, all small and dark, orbiting among the previously known satellites. It studied the rings in detail, measuring their structure and composition, and it measured the magnetic field, revealing its unusual tilted and offset configuration. The flyby was brief, just a few days of close observation as the spacecraft sped past, but it provided a wealth of data that transformed our understanding of Uranus. Voyager 2 also observed the moons in detail, revealing their varied surfaces for the first time. The images of Miranda showed the strange patchwork terrain that has intrigued scientists ever since, while the other moons displayed their own unique features, craters and valleys and scarps that told stories of ancient impacts and geological processes. The spacecraft's instruments measured the composition of the moon's surfaces, finding water ice and possibly other materials, adding pieces to the puzzle of how these distant worlds formed and evolved. After its encounter with Uranus, Voyager 2 continued on to Neptune, completing its tour of the outer planets before heading out of the solar system. The spacecraft is still functioning, sending back data from interstellar space, a testament to the engineering and planning that went into its design. The data from the Uranus flyby remains the most detailed information we have about the planet, and it will likely remain so until another mission visits this distant world, something that has been proposed but not yet undertaken. Another quiet detail is that Uranus's orbit is nearly circular, with only a slight eccentricity, meaning the planet maintains a relatively constant distance from the Sun throughout its year. This circular orbit, combined with the extreme tilt, creates the unique seasonal pattern where each pole alternates between decades of sunlight and decades of darkness. The equatorial regions experience more moderate variations, with the sun crossing the sky each day but with the angle of illumination changing slowly over the course of the 84-year orbit. The study of Uranus from Earth continues, with modern telescopes and techniques allowing astronomers to observe the planet in different wavelengths of light, revealing clouds and atmospheric features that are invisible to the human eye. Infrared observations show bright spots where the atmosphere is slightly warmer or where clouds are rising from below. Radio observations can detect emissions from the magnetosphere, providing information about the planet's magnetic field and its interaction with the solar wind. Each new observation adds a little more to our understanding, filling in details and raising new questions. Slowly, as we drift onward, we can think about what it would be like to approach Uranus in a spacecraft, watching as the planet grows from a distant point of light to a visible disk and then to a world that fills your view. The pale blue-green color would become more apparent, a soft, soothing shade that covers the entire planet. The smooth atmosphere would show its subtle variations, faint bands and occasional bright clouds drifting across the face of the world. The rings would come into view, thin dark lines encircling the planet, and the moons would appear as small crescents or disks, each one reflecting the faint sunlight in its own way. If you're still awake, that's perfectly fine. These gentle facts about Uranus continue to flow, each one a small piece of information drifting past quietly, asking nothing of you, just offering calm observations about this distant ice giant. The atmosphere of Uranus is composed primarily of hydrogen and helium, with a few % of methane and traces of other compounds. The hydrogen and helium are colorless, but the methane absorbs the red wavelengths of sunlight, leaving the blue and green to dominate the planet's appearance. Below the visible cloud tops, the atmosphere becomes denser and warmer, and at some depth it transitions into the ice mantle, though the exact boundary is gradual and difficult to define. The atmosphere is relatively thin compared to the planet's total size, forming a layer that wraps around the deeper interior like a skin. The pressure and temperature increase as you descend through the atmosphere, and at some point the gases become so dense that they start to behave like liquids. Deeper still, the pressure is so great that the ices are compressed into exotic states of matter that do not exist naturally on Earth, forms where molecules are broken apart and reformed into different structures. These high-pressure ices make up most of the planet's mass, creating the mantle that surrounds the core and giving Uranus its character as an ice giant. The core of Uranus, if it exists as a distinct entity, is likely made of rock and metal, similar to the cores of the other giant planets but smaller in proportion to the total mass. The core may be about the same mass as Earth, compressed into a smaller volume by the tremendous pressure from the overlying mantle and atmosphere. The temperature at the core could be several thousand degrees, warm despite the planet's cold exterior, heated by the residual energy from Uranus's formation and by the slow release of gravitational potential energy as the planet very gradually contracts. Another gentle detail is that the rotation of Uranus creates a day-night cycle in the equatorial regions, but because of the tilt, the poles experience very different patterns. When a pole is facing the Sun, it remains in sunlight continuously for 42 years, the Sun circling around the horizon rather than rising and setting. When a pole is facing away from the Sun, it remains in darkness for the same long period, a polar night that lasts for decades. The equatorial regions have more regular days and nights, but the angle of the Sun changes dramatically with the seasons, creating a pattern that is unlike any other planet. The temperature of Uranus does not vary much between day and night or between the sunlit and dark hemispheres, despite the long periods of continuous sunlight or darkness at the poles. The atmosphere circulates heat efficiently, redistributing warmth from the sunlit regions to the dark ones, creating a fairly uniform temperature across the planet. This efficient heat transport is one reason why Uranus appears so smooth and featureless, without the strong temperature contrasts that drive vigorous weather on other planets. The faint rings of Uranus are composed of particles that are very dark, reflecting only about 2% of the sunlight that strikes them. This darkness suggests the particles are made of carbon-rich materials or have been darkened by radiation over time. The particles orbit the planet in narrow bands, kept in place by the gravity of the shepherd moons and by the balance between various forces acting on them. The rings are not solid or stable in the long term but are constantly being replenished by new material knocked off the moons or removed as particles spiral inward or are lost to space. Slowly, the description continues, thinking about the moons of Uranus and how they formed. The large moons likely formed from a disk of material that surrounded the planet during its early history, material that gradually coalesced into the satellites we see today. The small irregular moons may have formed differently, either as fragments from collisions or as captured objects that were passing by and were pulled in by Uranus's gravity. The exact history of the moon system is not fully known, but each moon carries clues in its surface features and composition, evidence that can be studied and interpreted to piece together the story of how they came to be. The moons orbit Uranus in the same direction as the planet rotates, and most of them orbit in nearly circular paths close to the planet's equatorial plane. This orderly arrangement suggests a common origin, a formation process that created the moons in a disk that was already organized and aligned with the planet's rotation. The tilt of the system means that the moon's orbits appear to stand on end at certain times, creating a unique geometry that is unlike the moon systems of the other giant planets. If you're still awake, that's perfectly fine. Let your mind continue to drift with these details, floating gently through information about Uranus, a world that exists in the quiet cold of the outer solar system, far from the warmth of the sun, turning on its side as it follows its slow orbital path. The distance from Earth to Uranus varies as both planets move in their orbits, but at its closest, Uranus is still well over 1.5 billion miles away. This vast distance makes the planet difficult to study, requiring powerful telescopes to see any detail and making spacecraft missions challenging and expensive. The faintness of sunlight at Uranus means that solar panels are less effective, and the long travel time means that missions must be carefully planned and built to last for many years. Despite these challenges, there is interest in returning to Uranus with a new spacecraft, a mission that could orbit the planet and study it in detail over multiple years, observing the changing seasons, studying the moons, and exploring the magnetosphere. Such a mission could reveal much about how ice giants form and evolve, how their atmospheres circulate, and what their interiors are like. It could also explore the moons in detail, searching for signs of geological activity or even subsurface oceans, though the cold temperatures make the latter unlikely. The study of Uranus also informs our understanding of exoplanets, planets orbiting other stars. Many of the exoplanets discovered so far are similar in size to Uranus and Neptune, falling into the category of ice giants or mini-Neptunes. By studying Uranus in detail, we can learn about this class of planets and apply that knowledge to interpreting observations of distant worlds. Uranus serves as a nearby example, a planet we can study directly, providing a template for understanding the thousands of similar worlds that exist throughout the galaxy. Another quiet detail is that Uranus is just barely visible to the naked eye under perfect conditions, appearing as a very faint star that requires good eyesight and dark skies to see. Most people need binoculars or a telescope to spot it, and even then it appears as a small greenish disk without any visible features. The planet's faintness and lack of drama make it less popular among amateur astronomers than the brighter and more visually striking Saturn or Jupiter, but for those who seek it out, Uranus offers a glimpse of the outer solar system, a connection to the distant reaches beyond the familiar inner planets. The name Uranus comes from Greek mythology, the personification of the sky and the father of the Titans. The name was chosen to continue the tradition of naming planets after mythological figures, and it fit the pattern of naming the outer planets after more ancient and distant deities. The name has been used since the planet's discovery, and while it can be a source of amusement in some languages, it is the accepted scientific name and is used respectfully by astronomers and planetary scientists around the world. Slowly, as the description moves toward a close, we can reflect on the remoteness of Uranus, its position in the outer solar system placing it in a realm that is far removed from the familiar warmth and activity of the inner planets. Uranus exists in a state of cold stillness, a world where change happens slowly and where the energy from the sun is barely enough to drive the faint weather in the atmosphere. The planet rolls along its orbital path on its side, experiencing seasons that last for decades, a cycle that has repeated for billions of years and will continue for billions more. The moons of Uranus circle the planet in their tilted orbits, frozen worlds marked by ancient craters and long quiet geological processes. The rings drift in their narrow bands, dark and faint, composed of particles that have been orbiting for perhaps millions of years, kept in place by the gentle gravity of the shepherd moons. The magnetosphere wobbles and rocks as the planet rotates, creating a complex environment that extends far out into space, interacting with the faint solar wind that reaches this distant region. If you're still awake, that's perfectly fine. These final thoughts about Uranus are simply here, drifting past like the planet itself drifts through the outer solar system, a quiet presence in the cold and dark, far from the sun, a world that exists in its own slow rhythm, turning peacefully in the silence of space. Uranus is a reminder of the diversity of worlds in our solar system, a planet that is unlike any other, with its extreme tilt, its smooth blue-green atmosphere, its faint rings and varied moons. It shows us that planets can form and exist in many different configurations, that there is no single template for what a world can be. The study of Uranus expands our understanding of planetary science, adding another example to the collection of worlds we have explored, each one contributing to the broader picture of how the solar system formed and evolved. The planet continues its journey around the Sun, moving through space at a distance of nearly 2 billion miles from the warmth and light that sustains life on Earth. The journey is long and slow, 84 years to complete a single orbit, and during that time the planet experiences seasons that are unlike any we know, with decades of continuous sunlight at one pole followed by decades of continuous darkness. The equatorial regions see the sun rise and set each day, but the angle changes slowly over the years, creating a gradual shift in the seasons that plays out over the course of the long Uranian year. And so the description of Uranus comes to a gentle close, not with drama or excitement but with a quiet acknowledgement of the planet's existence, a distant world that continues to turn and orbit in the far reaches of the solar system, wrapped in its pale blue clouds, attended by its moons and rings, a place of profound cold and stillness, a world that has been there since the solar system formed and will remain there long after we are gone. A peaceful presence in the outer darkness, a planet that asks nothing of us but rewards our curiosity with the beauty of its color and the mystery of its tilted rotation, a world that drifts through space in its own quiet way, patient and serene, existing in the slow rhythms of the outer solar system, far from the sun's warmth, a reminder of the vastness of space and the diversity of worlds that inhabit it, turning slowly, peacefully, in the eternal silence of the cosmic night.